there are 8 billion people on Earth, and it would be better if there were none.
That's dark.
But like, imagine if we wake up one day and Seattle's gone. 13 million people dead.
Elon Musk sounds the alarm on an impending natural disaster that could have catastrophic global consequences.
Some of these conspiracy theories have turned out to be true.
The risk of these Arctic landslides is increasing because of climate change, according to scientists.
So even if there's catastrophic climate change on Earth, life continues. It just may not be the life as we know it. It may not be humans, it'll be something else.
A massive underwater crack forming deep beneath the ocean is threatening to trigger the largest tsunami in human history.
The U.S. Geological Survey is reporting a magnitude 7.6 earthquake off the Philippines. A tsunami warning has been issued in the Southwest Pacific Ocean, that quake just hitting.
A state of natural disaster as extreme flood.
And assess the potential implications of such a catastrophic event. We'll also dive into the role of technology and innovation in predicting and potentially mitigating these kinds of natural disasters. Buckle up as we embark on this deep dive into one of the most alarming scenarios in modern science. Chapter 1. Understanding Tsunamis. Before we delve into Elon Musk's alarming prediction, let's start with the basics. What exactly is a tsunami? Definition and formation. A tsunami is a series of powerful ocean waves caused by large-scale disturbances. These disturbances can include underwater earthquakes, volcanic eruptions, or landslides. The most common trigger is an earthquake beneath the ocean floor. When tectonic plates shift, they displace large volumes of water, generating waves that travel across the ocean. Unlike regular waves, tsunamis can travel. Historical examples. The 2004 Indian Ocean tsunami, triggered by a massive earthquake off the coast of Sumatra, is one of the deadliest tsunamis in history. It resulted in over 230,000 casualties across multiple countries. The 2011 Tohoku tsunami in Japan, caused by a 9.0 magnitude earthquake, devastated entire communities and led to significant loss of life and damage to infrastructure. Understanding these basics provides a foundation for grasping the gravity of the scenario Musk has presented. But what exactly is this deadly underwater crack? And why is it so concerning? Chapter 2. The Underwater Crack Phenomenon. What is an underwater crack? An underwater crack or fault is a fracture in the Earth's crust located beneath the ocean. These cracks can be the result of tectonic plate movements or volcanic activity. The East Pacific Rise, a mid-ocean ridge known for its tectonic activity. Potential for disaster. The concern with an underwater crack causing a tsunami arises from its potential to displace a massive amount of water. If the crack is significant enough, it could trigger a substantial underwater earthquake or landslide, leading to a tsunami. The size and impact of the tsunami would depend on various factors, including the magnitude of the initial disturbance, the depth of the crack, and the distance from populated coastal areas. Chapter 3. Elon Musk's involvement. Musk's background in science and technology. Elon Musk is known for his ventures in space exploration, SpaceX, electric vehicles, Tesla, and sustainable energy, Solar City. His interest in scientific and technological advancements often puts him at the forefront of groundbreaking discussions. Musk's theory, or a combination of both. Possible motivations. Musk's statements could be aimed at raising awareness about potential natural disasters and encouraging the development of technologies to mitigate their effects. His interest in addressing global challenges through innovative solutions aligns with his broader vision of making life multiplanetary and advancing human technology. Chapter 4. Scientific Basis and Theories. Current scientific understanding. Scientists use various methods to study underwater faults and predict potential tsunamis. These include seismic monitoring, satellite observations, and underwater sensors. The Pacific Tsunami Warning Center and other research institutions are actively involved in tracking and analyzing seismic activity to provide early warnings and assess risks. Theoretical models. Theoretical models of tsunami formation help scientists understand the simulations and computer models are used to predict the effects of different scenarios, including the impact of large underwater cracks on coastal regions. Chapter 5. Potential impacts and consequences. Impact on coastal communities. A massive tsunami triggered by an underwater crack could have devastating effects on coastal communities. The immediate impact would include flooding, infrastructure damage, and loss of life. Long-term consequences could involve economic disruption, environmental damage, and displacement of populations. Global implications. Beyond the immediate area affected, a major tsunami could have global repercussions. This includes disruption of international shipping lanes, impact on global economies, and international humanitarian responses. The interconnectedness of modern economies means that the effects of such a disaster could be felt worldwide. These systems use seismic data and ocean sensors to detect potential threats and issue warnings to affected regions. Ongoing advancements in technology are improving the accuracy and timeliness of these warnings. Mitigation technologies. Various technologies are being developed to mitigate the effects of tsunamis. This includes tsunami barriers, coastal defenses, and advanced construction techniques. Innovations in engineering and materials science are enhancing the resilience of infrastructure against tsunami impacts. Research and development. Continued research into underwater faults and tsunami dynamics is essential for improving our understanding and preparedness. Investment in scientific research and technological development can help address the challenges posed by potential disasters. Chapter 7. Public awareness and preparedness. Educational initiatives. Public awareness campaigns and educational initiatives play a vital role in local communities. Developing and testing response plans can help ensure a rapid and effective response in the event of a disaster. Community engagement. Engaging with communities and stakeholders is important for building resilience and preparedness. Community-based initiatives and local partnerships can enhance the effectiveness of disaster preparedness efforts. Chapter 8. Elon Musk's role and influence. Musk's impact on technology and innovation. Elon Musk's influence extends beyond his own ventures. His focus on technology and innovation has inspired advancements in various fields, including space exploration, renewable energy, and artificial intelligence. Musk's statements and initiatives often prompt discussions and developments in related areas, including disaster preparedness and technological solutions. Public perception and media coverage. Musk's statements can handle disasters can help improve global resilience and preparedness. Chapter 10. Historical context of tsunamis. Understanding the potential impact of a hypothetical underwater crack requires a look into the historical context of tsunamis. By examining past events, we can gain insights into the magnitude and frequency of such disasters. Notable historical tsunamis. The 1700 Cascadia earthquake. On January 26, 1700, the Cascadia subduction zone off the coast of the Pacific Northwest experienced a massive earthquake. This event triggered a tsunami that affected the coastlines of Japan, illustrating the global reach of such disasters. The 1960 Valdivia earthquake. The strongest earthquake ever recorded occurred off the coast of Chile on May 22, 1960. The resulting tsunami caused extensive damage and loss of life along the coast of Chile. Scientists studying the dynamics of these events. By analyzing past tsunamis, researchers can understand the factors that contribute to their intensity and impact. Studies of sediment layers, historical records, and geological formations help scientists reconstruct the history of tsunami events and refine their predictive models. Patterns and frequency. Tsunami events are not random. They follow certain patterns based on tectonic activity, volcanic eruptions, and underwater landslides. Understanding these patterns can help in forecasting and preparedness efforts. Historical data indicates that some regions are more prone to tsunamis due to their geological settings. For example, the Ring of Fire, which encircles the Pacific Ocean, is known for its high seismic activity and frequent tsunamis. Chapter 11. Advanced Tsunami Prediction and Monitoring. To mitigate the impact of potential